interesting. I must have hit the caps lock or something. Houdini is case sensitive. No? Okay. Hopefully it won't crash again. If it does, we're in trouble. Okay, don't crash, don't crash. Okay, so, and that'd be enough to scare away just about anyone getting into the program. Okay, so basically what I did is this would be an object. Okay, we can have as many objects as you want, thousands of objects, doesn't matter, bones, cameras, lights, those are all examples of objects. But it shows up as this single kind of entity in the network view. Okay, now diving into here, I have more nodes. So now I'm in a geometry context. I'm dealing with the innards of that object in geometry. So this is these are two examples of Houdini contexts. An object level deals with transforms only, and it could represent anything. And geometry deals with processing polygons, points, primitives, volumes, things like that. There's other contexts too, like particles, dynamics, compositing, chops, which is motion, things like that. Okay, so here I'm going to actually modify this object a bit, change it from a primitive to a polygon, and let's say we put like a mountain on it. Okay, so see here I'm using this node-based approach to manipulate my object. Okay, I'll just mouse it. There we go. Okay. And then I'll put like a smooth on it. So here I'm going and stepping through my procedure. Starts off as a sphere, goes to a mountain, then gets smoothed. Okay? So that's your classic Houdini proceduralism right there. The process we just described. And everything back up here is just, you know, an object called Geo1. Okay, so that's Houdini. That's how effects are built in Houdini. Alright, so yeah, we're going to get a lot more detailed real quick, but does anyone have any basic questions before we get started? Here I'm just doing the visibility flag just to see my procedures. Okay, if I wanted to, I could have a completely different thing over here. So here I've got a box over here. Okay, so I can have multiple ideas going at the same time. Doesn't really matter. Now my object's a box. It never knew about the sphere in the first place, as far as the computer is concerned. But
so it's two different views, very clear.
Yep.
But you don't see the whole thing.
Yes. Yes. So here I can have a completely different idea going. Some people just keep like tests and like get hundreds and hundreds of nodes and tests just around, just in case they might use them later. You wouldn't do that in like a creation history or a hypergraph, but people do that in Houdini all the time. They just keep stuff around, keep it for later, hide it. It's very much an R&D approach to solving different problems, where they might copy and paste a certain part from one effect into another effect. That can happen. Okay, so let me open up a scene here. Let's see. I wonder if it's there we go. Desktop. Okay. Alright, so we're going to start off with the probably the funnest operation in Houdini. And of course you got to start with that, right? So it's basically to copy objects and produce an effect. Okay? So here what we're doing is I've got this grid and it's got a bunch of particles coming out of it. And then on these particles, we're randomizing the shape, and the color is going over a gradient, and we're doing the scale as well. Okay? So if we look inside of what this is, this is really just a grid, and it's being read into this object over here, this particle simulation, what I called it, and it's got just a few simple nodes. It's got a sphere, a box, and a donut. It's randomly switching between these things. It's scaling them. Then we've got our grid. It's got a particle simulation applied to it. It's got a few other things we'll talk about, like a color ramp and an animation curve, like that. And then we get stuff that's copied onto our particles, according to that. Alright, so yeah, let's just start off with that. Now, I guess the best thing to do would be to show you in probably 3 basic steps for this example, and we'll just try each step out on the computers. Okay. So yeah, let's just start from scratch. Okay. So I'm gonna drop down a geometry. There's quite a few different types of objects, but geometry is probably the one that most people will drop down into a scene most often. Okay, it's just Houdini is all about geometry. It's not as much of an animation, lots of objects, rigs, bones program. It's actually more about, people use it more for geometry, I think. Okay, so yeah, here's I'll call this my grid. Okay, and then going into this, I can change it from its default state, which is this default box thing. Okay, so I'm just gonna double click to go into this object, and here I have what's called a file sop. I'm gonna delete the file sop. Okay. A sop stands for surface operator. Okay, so I deleted that, and I'm gonna add a grid. There we go. Okay, and pulling up the parameters here, I can just hit P. You just manipulate it like you would parameters on another program, or attributes on a Maya or something like that. Okay, so we probably don't have to do any real modifications yet. Okay, because that's really just, we're starting with this. Okay, but I am going to add a normal. See, right now this thing doesn't, well, it actually does have a normal, but I'm just going to go ahead and make sure it's pointed in the direction we want and everything. So for that, I'm going to do one more operation. Just do a facet sop. And I'm just going to cuss the polygons and, oops, post-compute the normals. And that pretty much on any geometry guarantees that I have normals facing like outwards from the polygons. Okay, so that's all I'm going to do. Now, if I were to set the visibility flag on this one, then it would have no knowledge at this level of what I had done. But if I want that other operation on there, I would set the visibility on that one, and then now it is with those changes. Okay. Okay, so now I've got a grid. It's not doing anything. It's just static. Doesn't really know. Nothing's going on yet. Okay. So now I'm going to keyframe this thing. It's going to make it move around, and that way we can spray our particles around. Okay. So I'm going to hit enter, and you know, your classic Houdini TD. If you get a guy that has been working with the software for more than 10 years, and you say the word keyframe, they're probably going to get scared, and you know. But yeah, Houdini does have keyframe features now. So you know, people do animate in Houdini sometimes. A lot of times people will do an equation for something, but right now we're just going to set some keyframes. Okay, so here I'm just going to go, and I'm going to go over to my translate, rotate, and scale, and I'm just going to hit the shortcut for it, or Alt left mouse. I'll just do that. That's just setting keyframes. You can always go to the menu, channels and keyframes, set keyframe if you want to do that way too. Okay, so I've got a keyframe on it. Let's see. It's not, there it is. Okay, and now I'm gonna go, let's see, a little ways. Let's just rotate it around, move it around. Okay, and I'll set my keyframes again. Okay. I just hit the S for the scale. That's all I did there. Okay. You can always move the numbers manually if you want to. So just do that. Okay. Okay, that's probably fine for now. Okay. So I've got a grid and it moves around. That's all we want to accomplish right now. Okay. So let's get over the first big hump of opening up the program, making a geometry object, going into the geometry object, making a grid, and a facet. This isn't completely necessary, so if you don't get this, don't worry about it. I'll be around to help. And then just go ahead and try to animate it. Okay, so that's we're going to get over the first giant learning curve here. Alright, and that should probably take like 15 minutes, I guess. So yeah, let's go ahead and get on those computers, and let's try to set that up. I'll help you guys as we do that. Okay, sorry about that. I should have asked them exactly about the procedures and stuff. So, okay, but yeah, I do feel that you know, seeing me do it is one thing, but even just the simple act of opening the software and setting up a few nodes on your own really does help it stick a lot better. Okay, so I've got my grid, and did anyone have any questions about just that? What happened there? Yeah.
When you create the geometry,
yeah,
you automatically put on the geometry group, or no? You need to create inside of the geometry group.
A geometry group is actually a concept that programs use differently. So a geometry group in Houdini is a piece of text that's associated with points or polygons or things like that. So what do you geometry? Do you mean like whatever is inside of this?
Yeah, because you didn't start as a sphere or as a grid, right?
Yeah.
It's a geometry group, right? Like a it's not a group, right? It's a container, I think.
It starts as okay. So the idea of an object versus geometry, right? I that might be. Basically, we can have objects in our scene. Like here's a biped arm, okay, whatever this is. Okay, it's actually got quite a few more objects in here. That's a bad example. Oh great. All right. Okay, so basically, if you are in a Maya, you're in the viewport, and you're clicking on objects. You're basically clicking on those nodes that we see in object view in Houdini. It's the same concept. Whereas if you were to go inside, if you were to go and modify the polygons of your geometry in Houdini, if you dive into that object and start pulling around polygons, I think it's like a right-click menu in Maya. Then you're actually inside of that object. The program is.
After you can access the different components of the object by diving.
Yes. This is a network-based approach. Yeah. So, and that's something I didn't really understand. I actually learned more about when I was using 3D Studio Max. I transitioned to Houdini. And I actually learned more about 3D Studio Max because I was trying to learn Houdini, because I didn't really understand that there were objects versus geometry. I thought they were kind of the same thing. An object is, think about an object like a placeholder, a null, let's say. And it could have anything associated with it. It could have a light associated with it. It could have a camera associated with it. It could have a piece of geometry associated with it. The program keeps track of itself with objects. Okay. Now, these objects can, you can have any number of operations and parameters and things that are affecting these objects. So in Houdini, there's a very clear separation between what an object is and what geometry is, and that isn't really common in other programs because they just want to get it in work. They don't want the artist to have to think about, okay, object, geometry, all this stuff. They just want to get it in work. Whereas in effects, you have to be a bit more specific because you're designing a system as opposed to grabbing something and moving it or animating it, generally. So we're designing a system here that would take in any piece of geometry and do a particle effect off of it. Okay, so we would have a separation of objects between what's causing the particle effect and the system itself. So once again, I'll call this guy grid, and it starts off with just a few polygons in it, but that's not because it has polygons in it. It's because it has a file SOP in it that defaults to that. See, so once I get rid of the file SOP, it's gone. So now this object has absolutely nothing in it. It's a geometry object, but it has 0 polygons, 0 points, everything else. So, okay, so then if I had a grid, see now I've just got this collection of polygons. This node is generating those polygons, and at object level, the only thing the program sees is a bunch of polygons. Yeah, okay. Alright, so from here, yeah, let's do a little animation. See, I don't have all those parameters that I used to have in the geometry. I just have basic controls for transform, because that's all objects do, is they have a placeholder and they have a transform. Position, rotation, scale. Okay, so I'll just animate that again. And yeah, let me go ahead and set up the effect this time. We can still start on it in basic pieces if we want, but I'll just go ahead and set up the effect from start to finish. And I think that'll give everyone kind of a good overall concept of a workflow here. Okay. Oops. Okay. Alright. Okay, so there's my animated grid. Let me go ahead and save this before it crashes. It's not the most stable program on Windows. The studio is using Houdini. It's going to probably be using it on Linux. So, okay. Let's see. Okay, so say this was anything. Right now it could be just any object, any piece of geometry. We'll call this any piece of geometry. Okay. Alright, so now I'm going to do another geometry object. And this geometry object, I'm going to have quite a bit more inside of it. It's going to house my effect, basically. Okay. So I'll call this particle effect. Alright. And here I'm going to merge. Sorry, guys. It's generally not this unstable. Good thing I saved. Okay. So I'm going to do a new geometry object. I'm going to call this guy particle effect. Okay. Going to delete the file stop. And we can still see this grid, but I don't think most people actually work that way. They like to hide the other objects. So here I'm only seeing the objects that are geometry that's in my object I'm into right now. Okay, so if I were to go back out, then I can see everything. If I go in here, I can only see my grid. Okay, so I'm kind of, you see how I'm kind of browsing around my scene like that? Okay, alright, so object merge. And I'm going to go to these parameters here, and I'm going to select some geometry to merge into it. Come on. There we go. Okay. So I'm just going to merge in particle effect. Alright. Oops, sorry. Wrong one. I'm going to merge in grid. You can't merge yourself into it. Okay. So, I merged in the grid. Now, the weird thing that just happened is that now I used to have an animated grid that was moved around, but here nothing happened to it. Okay, so it's like it never got animated in the first place. Now, that's because it merged in the geometry from the object, but it never actually merged in the transform information. So, if we wanted it to transform, we could say into this object, I think. Now it's got its transform applied to it, because this object's transform is 0, 0, 0, whereas this guy's transform is moving all over the place. Okay. So yeah, now we've merged in the object with its transform. Okay. Next is, let's just do a particle system off of it. So I'm going to do a POPs network. Now POPs are different than SOPs. You hear like all this talk like SOPs, POPs, CHOPs. SOPs are surface operators, and POPs are particle operators. Okay, so here I have a whole nother POPs network. See? So if I go in here, I'm inside of a brand new network. But this is actually a particle network, which is inside of a geometry network, which is inside of an object network. Okay, so these are networks and networks. It's kind of a different concept. It's not really like parent-child stuff. It's not like bones or anything like that. It's a network-based approach to setting up a 3D environment. Okay. So I'm gonna wire in my just like in Nuke, I'm going to wire in my geometry into this POPs network. Okay. And there's a different set of operators for depending on what context you're in. So here I get like, you know, rotation, speed limit, torque, all this particle stuff at geometry level, and they have quite a lot in geometry level. You get your geometry operations like you know, poly stuff, all that kind of geometry you're used to. It also has some very creative ones that we're going to get into in just a short while. Okay, so go into my POPs network. I'm going to do a source. Okay, and here, because I plugged it in, I can just say use first context geometry. Otherwise, I'd have to probably specify a SOP to use, but I plugged it in for that reason. Okay, so now I've got these particles being generated here. Okay, so those are particles. They're not really doing much yet. Who's worked with particles? Yeah, in a like which like, okay, so it'd be like Maya particles. Oh, okay. All right. So right now it's set to points ordered. We could do other things like surfaces random. There we go. So that's a little more random distribution. Okay. And attributes, it's using the inherited velocity, but we don't really have a velocity. Okay. So on my grid, I'm going to go ahead and notice that this guy does not have a normal. I middle clicked on it and it only has position. That's what that facet was for. So I'm going to go ahead, and even though I've animated it, I still can dive into it, change it around, whatever. I'm going to use my facet, and then I'm going to cusp and post compute my normal. Now it has these normals on it, these little lines here. And if I middle click here, I can see that it added that normal vector attribute. They're all pointing in this direction. So in my particle effect, now it should recognize that it actually has velocities going into it. It'll use the normals of geometry to move particles around. Okay. So now I've got more of a shape. Okay. We could stop there if we wanted to, but let's go ahead and just put on a force. It's one of your most commonly used pops. And give it some gravity. Who knows what the downward force of gravity would be in meters? Yeah. Alright. There we go. Okay. Now, they're falling straight down, so if I wanted to, we could just inherit the velocity times 10. Oops. There we go. Let's try this 100. Too much. Okay. Okay, so there's our particle effect. Alright. So we have a grid and a particle effect. If we wanted to, we could go back. We could change this. Let's wire in a box instead. We have a completely different effect. Okay. Looks like a small monster or something. Okay. So you see how proceduralism is starting to work here. Yeah, maybe it is more setup time than a shelf tool that you go and you click on something and it gives you a fire off of it, but this is how effects on movies are designed, because they need to be able to take in their geometry, which will constantly be changing, and they need to do effects off of that geometry, and then it needs to be art directable to the point where they you know, they can make a change like, oh, you know, we're gonna add a sword on this Spark's head or something, and now it's gonna be like an axe, and you need to be able to accommodate those changes. Okay, so we've got our grid, got our particle effect. Okay, and now let's put some stuff on these particles. All right, right now these things have a few other attributes. They have a velocity attribute, and they have, if we gave it one, an up vector. Okay, so does anyone know why you'd want an up vector? Okay, so basically, if you want to put stuff onto points, it needs a direction, and it also needs kind of a tilt so that you can control its orientation a little better, so it doesn't like flip-flop around. Okay, so I'm going to go back to my original geometry, and I'm going to put a point stop on it. Now, we're going to get into this a bit later in more detail, but for right now, I'm just going to add an up vector on the y-axis. Yeah. Okay. Okay, so now let's start with some more geometry. I'm just going to do a sphere for now. So here we have two different chains of thought. We have particle system on one side, we have geometry on the other side. Okay? Okay. This guy. Alright. And let's do a box and platonic solid, which would be our donut torus. Let's see. Or actually, wait a minute. There we go. Sorry. Torus. Okay. So box, sphere, torus. Okay. And now here is the funnest node in all of Houdini. It's the copy SOP. Alright, what do you think this thing's gonna do? Yeah. Alright, so I'm gonna put the sphere in one side, I'm gonna put the particles in the other side, and all of a sudden we get copies of the spheres. It's pretty cool, huh? What do you think? I was just completely floored the first time I saw this in a Houdini intro kind of thing like this. I was just like, oh my god, I've been trying to write Mac scripts for this for like, 2 years, and you tell me I can just plug it in one side and plug it in the other side, and it does that? It's not the same as instancing. No, instance is a reference to an object that exists, and this is actually an operation that will feed in geometry and actually make geometry duplicates of it. So at this point, this is a completely new set of geometry here. If I were to change stuff here, then it would change the end result, but at this point this is a completely different set of geometry. Okay, so I'll get more into that later. What do you guys think is going to happen if I instead of using the sphere, I plug in the box into here? What's that?
Instead of sphere, it would be box.
Yes. Cool. And same for the torus, right? Okay. Well, okay, so what about if I do another copy SOP and I make my my box really small? So I'm going to do a transform SOP, and I'm just going to scale down my box here and make it small. And I put my box in here and my torus in here. What I get then? I get copies a box on my torus. And now I can plug that into my copy SOP, and I get lots and lots of little torus boxes things. Okay, so yeah, the idea is that any step along the way we can change our procedural chain and we get different results. Okay, so this is definitely not instancing. This is a flow of data in geometry ops, geometry operations. It goes procedural like that. Okay. Yes.
It's more like
Yes.
I seem to understand more easily if you have a new.
Yep. Yeah, it's just like you plug in an image and then you might do like a time shift on your image, or things like that. Yep. Okay. So yeah, this is a pretty fun one. Here's another fun one. We're going to do a switch SOP. Okay, so a switch SOP does what it says. It would switch between one piece of geometry and another piece of geometry. Now, on the surface, you'd be like, that's a stupid node. Like, why would anyone want to switch between one piece of geometry and another piece of geometry? And once again, when I first saw it used, I was like, I made Mac scripts for this. Why can't it be this simple in other places? But yeah, so I'm going to use a switch SOP. I'm going to save first. Okay. So switch will switch between one and the other. Okay, so right now I'm going to switch between my box and my torus based on this parameter. Not that big of a deal. Actually, there's a switch node in Nuke. For those that are familiar with Nuke. Yeah, it's pretty useful sometimes, isn't it? Yeah. Okay, and I'm going to put my sphere in here too. So now, if I go to 0, I get my torus. If I go to 1, I get my box. And if I go to 2, I get my sphere. Okay? Then I can plug that into my copy SOP. So now I'm going to get all spheres, boxes, toruses, but we're going to use the particle ID to randomly switch between these things. Okay? Or we could even do it based on percentages if we wanted to, or whatever. Okay, so see, off my particles, these attributes it added for me, I have a unique ID for every particle. Okay? So we might not grasp this concept today, but it is a fairly bread and butter concept. It's called copy stamping. Basically, if we go to our copy SOP and we say stamp inputs, I'm just going to give it a value. I'm going to say ID. And then here would be $ID. $ID is the local reference or link, called the local variable, to this ID attribute. So we're reading the $ID from our second input. So as it goes through this command and copies each of these pieces of geometry, it's going to get a unique value for this ID here. So in my switch, I'm just going to make a link to that value. And so if I have a link to that value, it'll just make a different piece of geometry on every, or random. So okay, so stamp, and this is an expression. I'm referencing to my copy SOP. I'm looking up the ID place that I just designated, and then the default value, if it can't find something, will be 0. Okay. So now I should have, if that went well, it didn't go well, what did I do? Invalid source index out of range, that's fine. Ah, there we are. Okay. So I should have a box, a donut somewhere in there, or no, it's just torus and box. Okay. So why is that? Well, my ID starts off at 1. So on the first particle, it's going to get a box right here. And on every particle after that, it's going to get a sphere. Not quite what we want. Okay, we actually want a random division between 0 and 2. Okay, so for that I'm going to use a random expression. Alright, So instead of a pure stamp expression, I'm just going to encapsulate that in a random expression. These are just like expressions in Nuke or Maya. Okay, so I'm going to say rand stamp of my ID. Alright, kind of. Okay, so now I have random values between 0 and 1. So I get half 0, which is torus, and half 1, which is box. But I want between 0 and 2, so I would just multiply that by 2, or I could use a fit expression. Okay, so let's go ahead and try to multiply that by 2. There we go. Now, because I'm using ID, our points will always be consistent through the length of our effect. Okay, so we're not going to get, we shouldn't get these things changing. I mean, they keep birthing, so those are fine, but they're not going to change midstream here. Even if I have like a short lifespan, they won't change. So here, I'm gonna, instead of the life defaults to 100 seconds, which is very, very long, we're going to put the life to 1 second, or it's 1.5 seconds. Okay, 36 frames. Now it should be dying off pretty soon now. There we go. And let's make it a little longer. Okay.
Is it just me, or is Houdini pretty snappy interface? It seems to be staying quite quick, and then
Well, it's pretty light right now. Yeah, it's one of the major complaints about Houdini is how slow it deals. Once again, it's in the millions of polygons. So they're working on that, and Houdini 12 is known to be a highly, highly optimized version. So I've been trying it out for a few months. It's a lot better, but the types of things people are trying to do in Houdini, like break a giant mountain range or something with like millions and millions of rocks. I mean, I think the type of work Houdini does dictates the fact that it will be a very slow interface sometimes, unfortunately. So with this, it's quick. Yeah. Fire effects and giant breaking rocks and crowds, those are slow things no matter what program you use. Yeah. Okay. So now watch what happens if I use $PT instead of $ID, because I see this a lot when people just get into Houdini. ID, the particle system gives it that, but $PT is universal to all geometry. It just means point number. Okay, so if I do that, okay, so I get different geometry. You'll see that it's going to be stable until it dies, but then it's going to start randomly switching that geometry because our point counts are changing consistently. So it's that kind of stuff we got to watch out for when we do things like this. Okay. All right. Cool. All right. So I think for you guys doing a setup, this is probably good. I'm going to go ahead and add 2 more things for it for the sake of seeing what it can do, but I think we'll probably only have about 20 minutes to just put together this example, what we see right here. But let me go ahead and add some color and scale to it, just so you guys can kind of see how this procedurals and stuff works. Alright, so I'm going to do a point SOP. Now I said I'd explain this guy a little bit later, so this is later. Alright, so the point SOP is a very heavily used SOP. It's a workhorse. Basically, it's been with Houdini since the start, and it just adds these attributes to geometry. Okay, so if I wanted to add color to my points in space, I just added color. And the thing about Houdini you have to get used to is that it's not enough just to know that you added color. Like, oh yeah, I remember I added color. Yeah, it's colored. It actually shows you on there. See, so you're constantly like checking what attributes are on your geometry as this flows through your system. So notice we had an ID attribute. We used that a while ago, right? Well, now we just added color, and I can see that shows up as CD in my geometry. If I wanted to look at a spreadsheet of this, see, now I can see that I have all these different attributes and what their values are. So my CD 012 red, green, blue is white right now because it's 111. Okay. Alright, let's change that a bit though. I'm going to add a parameter. In Maya they're called attributes, I believe. I'm going to add a parameter, which is what they're called in Houdini. I'm going to add a color ramp. There we go. Okay, so this is the name of it as far as the program is concerned, and this is just what you see on the interface. Okay. So I just I drug that up here. I'll just do this. We'll see it a little better. Oops, sorry. Should have been a color ramp. Wrong one. I'll just delete this color here. Okay. Where's my color ramp? Ramp color, there we go. Okay. Okay, so here's my color ramp. So I just added a new little user thing, and right now if I do it, it doesn't do anything. See, it doesn't change the color of these points at all, right? Okay. But okay, well let's go ahead and make a noticeable color ramp here. I'm going to put like green and red, blue. And just before they die, they're going to get really dark. There we go. Okay. So I can reference this into here. Alright? So I'm going to copy this guy and paste it with it. It'll put an expression there for me to use it. Okay? So this actually isn't the right expression for it, though, unfortunately. It would be like the right expression for it if I were to copy this, because it's an individual color. So I'll do that. So now if I change this, it just changes, you know, that parameter. But I actually want to use the ramp more as a particle traveling through this ramp idea. So we have to do a little bit extra. We have to use the channel ramp expression. All right. So, alright, so I'm going to copy this instead. Alright, ch ramp. Okay, and this needs an extra few pieces of information. It'll just tell you right here when you're diving into expressions in Houdini kind of what it expects. And it's also in the help. So, ch ramp, it needs a ramp path, which it has. See, it's got a path for the thing I just made. It needs a position, so that means 0 to 1 for position. And then it needs an index, which means RGB, like what color is it. So, alright, so, okay, a position, that can be, let's say 0.5 for now. And our index would be red because I'm in the red channel. Okay. I'm going to copy and paste this guy. Uh-oh. Hope it doesn't crash. Oh, there it is. Sorry. There we go. Okay. No, Control C. Control V, Control V. Okay, so now I am actually accessing my ramp, as I think I am. Okay, yeah, see, I'm moving this around, and it's definitely doing something. This needs to, it's getting the red channel though, and this needs to be the green channel, and this needs to be the blue channel. Okay, so now it's getting 0.5 of the way into my ramp. So you see here's like blue, it's 0.5, and here's you know, it's kind of purpley now. Okay, we put like a red in there. There we go. See, the red's in the middle now. So it's getting 0.5 with the distance between this one and this one. So what would be an interesting thing to plug in there to make a particle effect with different colors instead of 0.5? Like what kind of, if you guys have worked with a little bit of particles, or what would what are some of the things particles have on them? They have an ID, we know that.
Age?
They do have an age. Yes. Age is the number of seconds it's been alive. That could be cool. Houdini has a life as well. It has a life from the time it gets born to the time it's going to die. So that goes from 0 to 1. And that would be a pretty straightforward thing. It could start off with its life at 0 here, and it could go all the way to life of 1 over here. Okay, so instead of 0.5, I'm just going to put in life. There we go.
Is it always uppercase?
That's the convention. You can make it any kind of thing you want, but these are just Houdini ones that it puts in for you. So it follows their convention. So anytime you have a particle system, it's going to give you ID, uppercase ID, life, uppercase life, age, uppercase age. But I could make my own attribute create, and then I could give it like, here's the local variable for it, so my attrib, and I could call that banana. Okay, so then it would say $banana, and I would get my attrib. But the Houdini convention would say this should be called my attrib. That'd be the convention. Yeah. All right. So okay. So now I've got a spread of color here because we're using life off of the particle system. So there it goes. And changing our ramp will change the value across this. Very similar to, if anyone's ever used Afterburn, it's very similar to that. Okay. And then okay, well that's kind of boring though, because I still get my gray shapes, but we can tell it to use the color. We could do the same technique, and we could put color here, and then we could find a color red, color blue, color green. We could just do a stamp expression and do a point stop on the other side like this. Or it's a little easier in this case because it's very much built to work with points in this respect, so we can just say use template point attributes, and it'll do it. Now you can't see it, but these spheres are actually changing colors. They're just a different kind of thing. They're a primitive. I'm just going to change that to a polygon so it all works the same. There we go. Alright. And one more trick here. Instead of using a color, I'm just going to use a color ramp rather. I'm going to use an animation curve. Animation is used for just straight up animating a grid like we did, but it can be used for just about anything else too in Houdini, and that's a really unique area that I'm particularly drawn to. It's very useful for crowd animations, organic animation, all kinds of stuff, procedural animation. A simple curve can be turned into a really powerful lookup procedure. Alright, so I'm going to add another parameter in here. I'm just going to add a simple float. Anyone know what a float is?
Well, we just had a day workshop on Python yesterday, so she's doing a float.
Ooh! Yeah, what is a float anyway? Okay, it's not a whole number. It can be like 1.1, 1.2, negative 2.3. It's a I don't know, floating point number. Okay, so for this floating point number, we could do this, and we can use this parameter to control the p-scale. So here's another Houdini default attribute, and it's the scale of a particle. It's p-scale. So I'm going to go ahead and just paste that channel into there. There we go. So now I'm using this channel up here to control my p-scale attribute right there. If I look in my spreadsheet, p-scale, p-scale, p-scale. There it is. Okay, so you see it set each point's p-scale to the value in that parameter. Okay, not too exciting yet, except for the fact that we can slide that around. But we could have slid it around anyway. What's the big deal? Well, we're going to use an animation curve on this channel. So let's see. We'll put a keyframe here. Uh-oh, wrong key again. Okay, keyframe, keyframe. There we go. Okay, so I'm just going to set this keyframe to frame 0. I'm going to set this keyframe to frame 100. Okay, and then okay, I just homed the view there. Okay, so alright, and let's set them both to a value of 0 as well. There we go. Okay, so frame 0 to frame 100, value is 0. Alright, our things just disappeared because they're small. Okay, now in the middle of the timeline, I'm going to put another keyframe and make a little ramp here that goes up and then down again. Okay? Alright, so guys remember what that looks like, okay? Alright. So if I just play my simulation now, it's being animated in two ways. It's being animated by the particles, and it's also being animated by the animation curve, which I guess that could be kind of cool, but I have to say I've never really seen an effect that needed that. But I have seen lots of effects that needed smooth transitions between you know, a starting point and an ending point. So we're going to, in the same way that we reference this ramp, we're going to reference this animation curve. Okay? So down to my particle scale over here, instead of the channel expression, so I'm going to, it pasted an absolute reference instead of a relative reference. See how it goes? Object, particle effect, 0.1 curve. That's an absolute reference. It's like the whole scene hierarchy there. I'm just going to paste a relative reference. That's a little easier. Okay, so instead of channel curve, I'm going to do channel frame curve, and that's a different expression. The channel expression just finds the shear value at that frame. The channel frame curve, you can actually specify your frame. So you just need two instead of one here. See, channel, it just says string channel. Channel frame, it has a float frame right there. So for my second value, I'm going to use life. But that's not really going to do what I want at first, because they're going to be extremely, extremely small. See that? So why are they so small? Well, because I'm only getting the first frame of my animation. Life goes from 0 to 1. And my animation I did was from 0 to 100 frames, right? And that's because I couldn't get enough resolution off of a keyframe. Just like 0 to 1 keyframes. You know, we need more frames to work with, right? So instead I'm going to do life times 100 times 100, and that'll actually get the frames over my full animation range. There we go. So now they start off small, they get big, and then they end small. There we go. There we go. Alright. The reason they look a little strange is because they're also using the normals from the particles. I'm just going to say only use CD for that. There we go. There we are. So now we're using both an animation curve, our ID, and we're using P scale, we're using life, and an ID to manipulate these points. Okay. So does that kind of give you guys a sense for a little bit of Houdini proceduralism? Okay. Yes.